Welcome. In this video, we'll be rewriting expressions in radical form. Let's take a look at example 1. Write the following expression in radical form. X to the 5/3. Well, the first thing first. Here, whenever you have an expression, let's say you have the base to the exponent P over Q. Remember that your P is your numerator and Q is your denominator. Then we can say we have the following. This would just be x to the power of P under the qth root. Or equivalently, we can change the order here and we say, well, we have the base, we're going to take the qth root of that and we're going to elevate that to the P power. So in general, what you do is the following. You have the base to the numerator divided by the denominator, can be rewritten as the base to the power of the numerator under the denominator's root. Or if you change the order, you can say, well, I'm going to take the root based on the denominator and you're going to elevate that to the numerator's power. Now, since we have this explanation, we can now rewrite this. So here we have x to the 5/3. Notice that the 5 is your numerator and the 3 is your denominator. And in this case, your x is what we call the base. So following this approach, we can say, well, x to the 5/3 is the same as x to the 5th power, and then we're going to take the cube root of that based on the fact that the 3 is the denominator. Or equivalently, you can change the order. You can say, let me take the base, I'm going to take the cube root of the base, and then you're going to take that and elevate that to the 5th power. And that's how we write the expression in radical form. Let's do a couple more examples here. Example 2. Write the following expression in radical form. So notice here we have k to the 4/5, so we can rewrite this one as k to the 4th under the 5th root. Or equivalently, we can rewrite this one as, let's take the base k. I'm going to take the root based on the denominator. So let's take the 5th root. And then we're going to take this and we're going to raise it to the numerator's power. So in this case, to the 4th power. Let's see 2 more examples. Write the following expression in radical form. Now here, the only difference is that my base is no longer just b, but in this case, my base is 7b. So I'm going to just be careful there by taking 7b as my base. So I'm going to say, well, here I have a 7b, raise that to the 3rd power, and then I'm going to take the 2nd root, or the square root of that, and that is equal to, changing the order, we can say, let's take the base of 7b, let's take the square root of that, and then let's elevate that to the 3rd power. Now the nice thing though is that whenever you have a square root, okay, whenever this root has this particular number of a 2, this is the same as the square root, so we don't have to necessarily write down the 2. So this can be rewritten as, okay, you have 7b cubed under the square root, okay? Or you can say that you can take the square root of 7b, and then this will be elevated to the third power. So let's see one more example here. Example 4, write the following expression in radical form. Again, following the structure from before, here our base is 5, so we're going to take 5k. So we're going to take the 5k, we're going to elevate that to the 7th power, and then we're going to take the 4th root of that. Or we can say, well, let's change the order. So we take our base of 5k, let's take the 4th root of that, and let's elevate that to the 7th power. And this takes care of the expression being rewritten in radical form. So in this particular video, we focus our attention on rewriting expressions in radical form. Recall that if you have x to the p over q, where p is your numerator and q is your denominator, you can rewrite this one in the form x to the p under the qth root, or after you change the order, you can say, well, we take the qth root of the base, in this case x, and then we're going to elevate the result to the p power. So that takes care of how to rewrite expressions in radical form. Thank you for watching, and have a wonderful day.